Good evening students. Today what we are going to see is the next type of reactor in the classification that we already seen, process intensification. Process intensification in the last lecture we saw what we mean by spinning disk reactor. Today we will see the next version of it, or a slightly different version, that is rotor stator reactor. So as the name implies, now that it will contain basically two types, two parts. One is a rotor. Rotor is related to rotation, something that is revolving, and second one is stator. Stator means something that is static. A reactor basically we are having two parts. One is a revolving part and the second one is a static part. Okay, so now what exactly is the construction of this? Okay, so this is a general or schematic representation of a tentative outlook of a rotor stator reactor. Okay, it is not the same for all the applications. Other applications not exactly same way. This is one of the applications that we can have. Okay, in this, if you can see, we are having two different portions in this reactor, exactly like a heat exchanger. This reactor, as we already saw, last reactor in the spinning disk reactor can also be used as a reactor as well as a heat exchanger. Heat exchanger ni jem use kari sakta. Evi જ રીતના આની અંદર પણ we can use this as a heat exchanger also. Now suppose if we are using this as a heat exchanger ની અંદર we know that there are two streams, hot stream and the cold stream. So the blue part that we are seeing, this is actually the part which is revolving. This is the part which is revolving, and this particular portion, this is the static container. This is actually you can say enlarged view. Through zoom in કરીને આપણે લોકો જોઈએ છીએ. Otherwise what happens is this difference, the distance between this is relatively very less. So what happens is here we are having two different streams, two different liquids which are in contact with each other, but they are having continuous shear against each other. The important term that we need to note in this is shear. When two bodies come in contact with each other and they are parallel to each other, okay, that is what is known as shear stress. You have longitudinal stress, you have tangential stress, but shear stress means two bodies are having friction or they are rubbing against each other. That is what is known as shear. In this case, if you notice, the outer cylinder will have a very thin layer of liquid along its walls, and the inner rotating thing, it will have a very thin layer on its inside. I'm again telling this, we are not talking in terms of a reactor. This is what we are talking in terms of a heat exchanger for easy understanding. So now if you imagine heat exchanging matter, we always require adequate or proper mixing. But here the films, the liquids, they are so thin, itla patala that immediately, the quantity being very less, there will be a very good heat transfer between them in a very short amount of time. Ocha time ni andar there will be a very good contact between them because they are very thin and they are rubbing against each other. So heat transfer will happen very fast. Now imagine this situation to be used for a reactor. एक reactor ની અંદર તમે આવી રીતે use કરો તો શું થાય? Exactly the principle that we talked in the spinning disk reactor. Reaction happens when you have adequate or proper mixing. તમારા constituents બરાબર મિક્સ થવા જોઈએ. So in this particular case what happens? The films, they are so thin. As I told you, this particular thing, it is a zoomed in format. But suppose if they are very close, it will be something like this. And when you are having a reactor as so then both of these two streams, they will be in contact. It will be something like here there will be one stream which would be revolving at a high speed, and here there will be one stream which is static. Both of them will come in contact with each other, they will rub against each other, and a very good you can say reaction will take place between them. There will be no mass transfer resistance, no heat transfer resistance. Both are reaction in our So when you are using this concept of rotor stator reactor, this is one of the things. Because of very good mixing, the reaction will happen very fast. We'll see what are the different fields in which this rotor static reactor is used. But we also need to consider that whenever a body is revolving, પાણી સપોઝ તમે લોકો ફેરવો બહુ સ્પીડમાં, what happens generally? One of the difficulties that happen, a bucket in there, if you take some water and you start revolving it at a very high speed, what happens? So when a body is revolving, one of the biggest drawbacks that happens in heat transfer as well as mass transfer is vortex formation. Just to show what vortex is something like, suppose it is a tank filled with liquid, and if you start revolving this at a very high speed, all the liquid goes towards the sides. Okay, so the liquid is now there on the sides. In this center, this entire space is hollow. This leads to very poor mass transfer, very poor heat transfer. Adequate mixing, all the things go towards the wall and they keep on revolving. It is a type of plug flow. In CRE, you would have studied what you mean by plug flow. For proper mixing, what you require is not plug flow, what you require is CSTR, continuous stirred tank reactor. So if you are having a plug flow, in that case, reaction, mixing, all these things will not happen. So now, as we discussed, here we are having a central shaft which is revolving at a very high speed, and an outside body which is at a static level. Now, if we don't control the parameters that we need to control is clearance, the gap between the static and the rotor body. That is the first parameter. Second one is the speed of revolution of this rotor. According to the application where we are going to use, if we don't control this, we have a problem which is known as Taylor vortices. Vortices means it's the plural of vortex. Vortex means in a plural beki sankhya. Okay, so if you do not handle these parameters properly, because one of the portion is revolving at a high speed, vortex form tavana chances છે. And for this revolving body, we call this as Taylor vortices. If Taylor vortices happen, in that case, તમારા જે reactor છે એની efficiency will go down to a very low value. Okay, so the main and important concept that we need to remember in this is this rotor stator reactor. The outer cylinder is static, the inner rotor is moving. Being in the thin liquid to film which is coming in contact with each other, they are having shear force, shear stress across each other. Very thin film, so very good heat transfer, very good mass transfer, as a result of which good reaction. But jo tame tamara parameters, that is this clearance as well as the speed of rotation, if you don't control these two parameters, in that case it may lead to Taylor vortices. Now jo Taylor vortices high, in that case what will happen is, I will exactly tell you what happens. It becomes this situation where the entire liquid is just going to revolve. The liquid and it will not lead to any mixing between these two or a reaction between these two. Okay, so it can be asked in exam, what do you mean by Taylor vortices? What is the, you can say, disadvantage or what is the precaution that you need to take when you are using a rotor stator reactor? Is this clear? Now some examples of rotor stator reactor or the applications of rotor stator reactor. For chemical synthesis, esterification, peanut oil is converted to soap in 11 seconds. Soap is prepared basically by esterification. You would have studied in your chemical process industries. Peanut oil is soap ma convert in just 11 seconds. That is the efficiency or speed with which this reactor can carry forward the reactions. About 300 times the rate is increasing. Normal it generally takes 1 hour, 2 hours, you keep on stirring the mixture and gradually it happens. But here, peanut oil can be converted to soap in just 11 seconds if you are using rotor stator reactor. Another one is polymerization. If you remember the previous example, we saw rotor stator spinning disk reactor, unique application made to polymerization. This reactor can also be used for polymerization reaction. Okay? 10 times faster than a batch reactor. એક બેચ રિએક્ટરમાં જેટલા સ્પીડથી રિએક્શન થાય એના કરતાં 10 ટાઈમ્સ વધારે સ્પીડમાં રિએક્શન કેન હેપન ઇન ધીસ. Okay, at lower temperatures. The temperature required is also not excessively high. Polyacrylates, 90% conversion in less than 20 seconds. Again, a sort of polymerization reaction, 90% upper conversion in less than 20 seconds. Solid synthesis. Synthesis means nothing else but manufacturing, producing, preparing. कोई वस्तु बनाओ. Synthesis of chemicals, so chemicals to manufacture. So when we talk of solid synthesis, particle size controlled by shear rate and residence time, about 3 seconds. Because of this particular gap, suppose if you are using this reaction to prepare any solid, તમે કોઈ solid ને બનાવવા માટે આ reaction use કરો છો, the particle size can very well controlled using this clearance. આવી વચ્ચેના gap base ઉપર તમે લોકો બહુ સારી રીતે તમારા particle નું size છે એને control કરી શકો. Okay, that is why I said in the beginning, depending on the application of this reactor, તમે કઈ જગ્યાએ use કરો છો, based on that you need to control the speed as well as the clearance. Okay. Bioprocessing, yeast fermentation of molasses decreased fermentation time by about 40%. Fermentation is one of the most important concepts of, you can say, biological field. Okay, fermentation in the time was reduced by 40%. So suppose 100 minutes lagta, and right now you can complete that same reaction in 60 minutes. Okay, again that is because of this particular rotor stator reactor. What we need to understand, or what we can summarize is, as we already discussed in the basics of process intensification deals with improving the efficiency of any process. So what we are doing here, જ્યારે આપણે processની વાત કરીએ, when we are talking of any reaction, it depends on various parameters, and the most important of them is proper contact between the reactants or might be the two phases. Heat transfer છે તો બે તમારા phases વચ્ચે adequate or proper contact. When you are talking of mass transfer or you are talking of any chemical reaction, there should be proper and adequate contact of both the components, both the substances, both the materials. So what we are doing in this type of reactors, you talk of rotating spin disk reactor or you talk of rotor stator reactor, you are not dumping. તમે લોકો તમારા reactants ને તમારા solution ની અંદર કે mixture ની અંદર dump નથી કરતા. You are adding them in a very controlled manner. एकदम controlled manner, એટલા નાના ફોર્મમાં તમે લોકો એને રિલીઝ કરો છો that immediately that quantity reacts with the reactants and you get the product. Okay, so this is what is the aim, or you can say the advantage of using a rotor stator reactor.